see any question you have? If you have any question till the point we have discussed last class, if you remember, we are discussing this problem, right? If you have any question about this up to this, please ask. Any doubt?
Sir, in case of UDL, sir, how we are going to solve this, sir?
UDL, okay, okay. See, UDL, see, this is the problem of UDL only. So this 2 kilonewton per meter load is UDL only, right? So what you have to do, you see, for UDL, you just place this UDL on the influence line, okay? So wherever this UDL is placed, for wherever this UDL is placed, on that on that influence line diagram, what you will have to do, you will have to just calculate the area of the influence line diagram, okay? So if you
Yes, sir.
calculate the area of the influence line diagram and then multiply that value with the value of the UDL, you are going to get the value of the shear force, bending moment, reaction for whatever the influence line you have. For that you will be getting it. Let's say for this problem, you see, this is the UDL 2 kilonewton per meter, right? So what is the length of this UDL? What is the length of this UDL? Bolo, tell me.
Sir, 7.5
Sir,
meters.
7.5.
Yes, 7.5 meter. Now you see, in this problem, you see, this is the influence line diagram for shear force at this point C, right? So when this load is moving, over this beam, okay, so at this at a particular instance, you see, this 4 kilonewton load will exactly be coming over this 7.75 ordinate, right? Exactly this 0.75 ordinate, this 4 kilonewton load will come. And then when this and after this 4 kilonewton load, this much load, this 2 kilonewton per meter load, which is having a length of 7.5 meter. See, this 7.5 meter, here is also the distance is 7.5 meter. So what you have to do, you calculate the area of this triangle. So what is the area of this triangle? The area of this triangle is nothing but half into 0.75 into 7.5 meter, and that is what actually is being done. See, half into 10 meter minus 2.5 meter means 7.5 meter into 0.75 into what you'll have to do, into you'll have to do the load, whatever UDL is there, so 2 kilonewton per meter. So that is going to give you the value of the shear force at this point C because of this moving load 2 kilonewton per meter. So maximum positive shear force if you want to have, then you see this 2 kilonewton per meter load, you will have to place where? You will have to place at a position where this 2 kilonewton per meter load is going to create maximum positive shear influence at point C. So if you see this 4 kilonewton load comes on this side, then what will happen? Then you are not going to get this full area of the triangle, right? So you are not going to get the maximum positive influence of shear. Now let's say instead of this 2 kilonewton per meter load, which is of 7.5 meter length, instead of this, let's say this load is of 5 meter length, then what will happen? Can anyone explain? Suppose this 2 kilonewton per meter load is not of this much length, okay? Let's say I am saying this, that let's say this load is just up to here, and the length of this load, let's say from here to here is 5 meter. Forget about this portion of the load. Let's say this portion of the load is not there, so let's say this is what happened. What is this? What happened? just a minute, some disturbance. Screenshot has come. Just a minute, let me close it.
CTRL plus Z यूज कर लीजिए.
Control Z. No, it's coming right from here. What is this? Oh, what is this coming? This screenshot something has come na here. Insert a picture of any program